chapter of your course book that is in AS level, is that? So today I'm going to explain all the points that you're familiar with these revision questions, is that? I'm going to explain all the lessons that you're already familiar based on this question. As you know, to solve any quadratic equation, in order to solve any quadratic equation, we can use three different methods, is that? Now the first method to solve a quadratic equation is a factorization method, and the second method is completing the square, and the third method is gonna be, that is the quadratic formula, is that? That means you can use either of these methods in order to find the solution of any quadratic equation in general. You can use these methods to find solution of this problem as a whole. So today, now this is the first point. First of all, you have to remember how we are going to solve any quadratic, whatever the quadratic problem in general it may be. You have to know how to use these three different methods in order to find the quadratic equation as we know, is that? So next to this, we have already seen how to solve more complex quadratic equation also. More complex quadratic equation based on substitution method. You already familiar. You know how to find a solution of a more complex quadratic problem based on substitution. And the other important point that you familiar, that you know in the course book, is how to find a solution of a system of linear equation, one linear, one quadratic. Is that how we are going to solve this equation in general? How we are going to solve system of an equation having one is linear and the other is quadratic? How are we going to find solution of this problem? You're already familiar how to do this problem in general, is that? So, in all cases, you already know, you're familiar how to find a solution of any quadratic equations and how to find a solution of the system of equation having one is linear and one is quadratic. And the other point, you already familiar how to find a solution of a complex quadratic equation, more complex quadratic equation. And the last point, you also familiar how we are going to determine number of roots of the quadratic equation. As you know, if the quadratic equation have one root, so the discriminant b squared minus 4ac should be 0. The discriminant means that, you know that b squared minus 4ac is the discriminant, this has to be 0. b squared minus 4ac is gonna be 0 if the quadratic equation has one root, is that? If the quadratic equation have two roots, b squared minus 4ac should be greater than 0, is that? If, you know that, if b squared minus 4ac is less than 0, now no root, is that? For this problem, no root. The quadratic equation never have a root if the discriminant b squared minus 4ac is absolutely less than 0, and for this, that is two roots, is that? For this case, the quadratic equation will have two roots, and for this case, the quadratic equation will have one root, is that? And you know that this is the discriminant, is that? Discriminant. This is the discriminant that you take from the quadratic equation. A, B, C. A means the coefficient of the leading term, B means the coefficient of the middle term, and C is the constant term, is that? So, taking all these important issues, you can insert in place of B, A, C, if b squared minus 4ac is absolutely 0, the quadratic equation always have unique solution or one root. If b squared minus 4ac is greater than 0, the quadratic equation will have two roots. And similarly, if the discriminant is less than 0, the quadratic equation will never have a root in general. So, what the meaning for this in general? The quadratic equation, the graph of the quadratic will never cross the x-axis. This is completely either above the x-axis or completely below the x-axis. If b square minus 4ac is less than 0, the graph of the quadratic function is completely below the x-axis or completely above the x-axis. This is the point that you have to remember on our lesson, is that? When you come to the second point, that means if b square minus 4ac greater than 0, means that the graph of this problem will be what? The graph of the quadratic function will cross the x-axis exactly at a point. Is that? That means the relation between the graph of the quadratic function and the x-axis will be 2 points. Means that the graph of the quadratic function intersects the x-axis exactly at a point. When you come to the first point, the graph of the quadratic function will touch only the graph of the function at a point. Is that? At a point. That means the graph of the quadratic function may open up or may be open down. Is that? If the graph of the quadratic function open like this, now this point will be the intersection of the graph of the quadratic and the x-axis. If the graph of the quadratic function open up like this one, this point is going to be the intersection of the x-axis and the graph of the function. So it will have one root. And the other point, which is quite different from this one, is if b square minus 4ac is greater or equal to 0, now the quadratic equation will have many solutions or any solution. Is that? That means if the discriminant b square minus 4ac is greater or equal to 0 for any a, b, c that we take from the quadratic function, the quadratic function will have infinitely many real, or it will have real solution. So these are the very important points that you familiar in the first chapter of your course book. So the other and the last point, you also familiar the relation between the equation of the line and the graph of the quadratic function. Is that? So if the quadratic function means that if the graph of the graph of the linear function crosses the quadratic function at a point, then the quadratic function will have a unique solution. Is that? Mean that if the graph of, assume this is the graph of the quadratic function and this is the line, if this line, as you see, the line, this is tangent of this one. So when we are equating, this is the linear function ax plus b, and this is the quadratic function ax squared plus bx plus c. Let's assume this is, let's change this one, dx, and let this be e. So if this is the graph of the quadratic function and this is the graph of the linear function, if the graph of the linear function is tangent of the graph of this function, so when we are equating this problem, ax squared plus bx plus c, that is gonna be dx plus e has unique solution. That has one root. Is that? Has one root. This means that b squared minus 4ac is going to be what? Exactly 0. You have to remember what you familiar this concept. Is that if the graph of the linear function only tangent of the graph of the quadratic function, or if the linear function exactly touch at one point for the graph of this problem, so you know that when we are equating the linear and the quadratic function together, this problem will have one root, means that the discriminant b squared minus 4ac is going to be 0. Is that? So this is the point that you already familiar in our previous cases. And the other point, if the linear function is secant of the graph of this one, assume this is the linear function which is secant, and let's assume this is again which is dx plus e. This is one. If the graph of the linear function is secant of this one, and you know that when we are equating this problem, b squared minus 4ac is going to be greater than 0, that means the equation this will have two real roots. Is that? The equation ax squared plus bx plus c, which is this, is going to have two real roots. Is that if the linear function is secant of the quadratic function? This is the point that you familiar in our previous cases. Is that? And the last point, means that if you know that if there is a line which is neither secant nor tangent, assumed to be the linear function is going to be like this one. If this is the graph of the linear function, this is neither tangent nor secant, assume this is y is equal to as dx plus e. If the linear function these will never touch and cross the graph of the quadratic function, then when we equate this linear and this quadratic function, the linear and the quadratic function, when we are bring together, now the equation has no solution. Has no solution means that b squared minus 4ac is absolutely less than 0 for the relation between this curve and this line. Is that? So this is the main point that you familiar in our previous classes. So this is the main revision part of the first chapter that you always remember on this one. So today, let me show you how to solve this problem. These problems are revision questions that I have taken from different past paper questions. Is that? So you know that all these questions are the past paper questions. These are past paper questions of May and March, March and June. Is that? They are taken from March and June past paper questions. And this is called, these past paper questions are taken from 2022. Is that? So all these questions are the revision questions that are taken from 2022 of March and June. So let's solve how we are going to do this problem. So based on this problem, let me try to revise what's just you familiar about chapter 1 of AS level mathematics course book. So let me try to revise based on this question in general. So the first point, how we are going to express this is in the form of this one. This is the question. How we are going to express x squared minus 8x plus 11. So look this one. Answer for this problem. Log place x squared minus 8x plus 11 should be what? We have to equate x squared minus 8x plus 11 as x plus p the whole square plus q. Is that? Look, mind you, you are asked to express this in the form of this one. So simply you can equate. Is that? That means when we are equating these and these, it's always the same. So you know that how to expand this problem. Is that? So when we are expanding this problem, what we're going to have? This is x squared plus 2xp plus p squared plus q. Is that? And you know that how to expand this problem. This means now this one. Is that? Because you know that x plus p into x plus p mean what? You know this is exactly this will x will multiply both these. X times x will be x squared, x times p, xp, p times x, that is xp, and p times p, that's p squared. So xp plus xp will be to xp. That's the case. So this is the way how to multiply this one. Is that? This is the way how to multiply this one. Then finally, you know that these two equations are same, 8x plus 11. So now we can equate. Now this implies that since these problems are the same, the leading terms should be the same, the middle terms should be the same, and the constant terms should be the same. So this implies that 2xp should be equal to negative 8x. So this x can be cancelled by this one. So this implies that p is going to be negative 4. The value for p is going to be negative 4. Similarly, now from here, p squared plus q should be equal to the constant, that's 11. But from here, p is already negative 4. Negative 4 the whole square plus q, that's going to be 11. Then, now this is 16. If you bring this on the right side, what you're going to have? Q is going to be 11 minus 16, which is going to be negative 4. Because you know that the same technique we already applied for the other problems that will be written here. Is that? If you understand this one, first of all, you have to understand how we are going to express, how we are going to describe this problem in terms of this one. That means you have to equate them together. Now we have this one. Then this is equal to this one. Therefore, now x will be cancelled out, negative 4. And p squared plus q should be what? Now you know that the sum of this will be 11. So this is negative 4 the whole square. Negative 4 the whole square means that's already 16. So you have to subtract this from 11. Now we have this one. So the value for p and q is going to be this one. And hence, now this is going to be what? This is equal to x minus p mean, that's negative 4 the whole square. And q is already negative 4, is that? So this is the way how to express this one. That means x squared minus 8x plus 11 is written in the form of this one. This is already expressed in the form of this one. For the second problem, this is an extended point. You are asked to solve how x squared minus 8x plus 11 is equal to 1. Here, you have to be careful how we are going to solve this problem. Sometimes you can bring this on the left, that will be 10, is that? So x squared minus 8x plus 10, which is going to be 0, you can solve this way. But you are not expected to do this way. What you're going to do, now to do this problem, since this and this are equal, means that x squared minus 8x plus 11 is equal to 1 mean, now this means that x squared, x minus 4 the whole square minus 4, that's going to be 1. So this is the way that you do. Therefore, x minus 4 the whole square is going to be, take this on the right side, that is 5, is that? When we take 4 on the right side, it is going to be this way. Then x minus 4 is going to be plus or minus radical of 5. So move this on the right, x will be 4 plus or minus radical of 5. So this implies that the value for x is going to be 4 plus root 5, or x is equal to 4 minus root 5. This is the way, you see? So that means you'll never just go to this detail. When you are asking to solve this problem, because solving this in the form of this one, expressing this in the form of this one is very crucial to solve this with simple way. That means, you know that this means this one. So you have to directly plug this one in place of this one. Then equate this way. Move 4 on the right. That will be 5. Then take square root both sides. X minus 4 left on the left, and we have plus or minus root 5. Then move negative 4 on the right. We have this one. So the solution will be this one. So it is over. Is that? It is over. Thank you. Now let's see how to do the second problem. Similarly, you are asked just to express this problem and the form of this one. How are we going to change this into the form of this one? It's a similar case what we have already done in the first problem, is that? But you are expected to know. Unless you know the way how to change this into this way, you'll never change if you have more problems is given that way. So how we are going to change this to this one? So look at this one. 2x squared minus 16x plus 23. Now this should be equal to 2 into x plus a the whole square plus b. Is that? So we need to expand this problem. How we need just expand this one? Based on the previous example of this one, now let's do this one. 2 into, this is x squared plus 2ax plus a squared plus b. Is that? So this is exactly given by 2x squared plus 4ax plus 2a squared plus b. This is the way. Is that? Then once you already done this way, now this is a constant. This is the constant, is that? So this is the middle term, and this is the middle term of the quadratic function. And this is the leading term, and this is the leading term. So the leading term and the leading term is already the same, and there is no other constant parameter, so no need to equate this one. Rather, we have to equate the middle term of this expression and the middle term of this quadratic expression. That is gonna be 4x, which is going to be 16x. That. Then you can just cancel x in both sides. So that's going to be 4a is going to be negative 16. You can divide both sides by 4. A is gonna be what? Negative 4. So this is the value for A. Then to do the other value for B, you have to take again 2a squared plus b. That's going to be 23. That? Because the constant in the expansion of this, the constant in this expression and constant in the left expression should be the same. So A is already calculated. So so this is exactly 2 into negative 4 the whole square plus b, which is 23. And you know this is 16 times this, 32 plus b, which is 23. So from here, you can say b is exactly 23 minus 32. And b is going to be, what's the solution for this one? What's the solution? That is 23 minus this means that's already negative 9. Is that? Negative 9. So this is the value for A and B. Once if you already calculate, if you just find the value for A and B, you can directly plug in place of A and B to express this in the form of this one. Is that? That will be now therefore 2x squared minus 16x plus 23 can be written as 2 into x minus 4 the whole square minus 9. Is that? This is already written this way. Is that? So, whatever a mathematical expression, whatever the quadratic expression it may be, if you are asked to express the given problem in the form of this one, you have to describe this way. Is that? So, it is written this way. That's over. We already just done the first case. Second problem, is that? So this is the way how to do second problem. Now let's come back to how to do the last question of this one. Now here, mind you, how we are going to solve this problem, is that? How we are going to find this one. You have already given a line this intersects at 2 distinct points of the curve of this one. Then how we are going to find the value of C? This is the question. As I have already mentioned, as I have already explained at the very beginning of this lesson, if a line is secant of the graph of the quadratic curve, so when we are equating this problem, b squared minus 4ac has to be positive. Means that when we are equating this problem, now this implies that x squared plus 2cx plus 4 is equal to 4ax plus c has two distinct rows. Is that? Distinct rows. Is that? So this is the point that you have to remember. Is that? That means if this an arbitrary line is secant of the graph of the quadratic function, so from here you can just deduce or you can conclude that when we are equating the quadratic and the linear function, this problem will have two real roots, and hence now b squared minus 4ac is greater than 0. So this implies that first let's rearrange this problem. That so when we are rearranging this one, x squared plus 2cx minus 4x plus 4 minus c is gonna be 0. Is that? So that means this will be reduced or given in the form of this one. Then you can equate this problem. X squared minus x, you can take out x, that is plus now 2c minus 4 into x plus 4 minus c, which is 0. And you know that from the quadratic concept, you know this is b and you know this is C, and only A is 1, is that? A is only 1. So from here, you know that B squared minus 4AC is greater than 0, is that? So what is B here? B means 2C minus 4, the whole square minus 4. A is already 1, C is already 4 minus C, which is greater than 0, is that? Then from here, you can just expand this problem again. When we are expanding this one, let me show you how to expand this one. 2C minus 4, the whole square means 2C minus 4 into 2C minus 4. Then 2C times 2C will be 4C squared. 2C times that, negative 4 will be AC, 4 minus AC plus 16. And this is going to be 4C squared minus 16C plus 16. That? So when we are expanding this problem, what we're going to have 4C squared minus 16C plus 16 minus this is 16 and plus 4. That's going to be 0, is that? So look how we are going to do this problem. This means 4C squared minus 16C. This is already 0, and we have plus 4 greater than 0, is that? So you can divide both sides by 4, and that is going to be C squared minus 4C plus 1. This is going to be 0, greater than 0. I think we have to do this way, that? Because you know that 4 AC mean 4 times A is already 1, and you can A is already 1, 4C mean we have this one. So 16 plus C is going to be correct, is that? It's going to be correct. I think it is correct, is that? So now we have this one. So now we have this problem. Let's see how we're going to do this problem. You have this case, C squared minus 4C plus 1 greater than 0. How are we going to find the value for this one? So we need to find two numbers whose P plus Q is going to be negative 4 and PQ is exactly 1. What are the numbers whose sum is exactly negative 4 and whose product is already this one? Who can tell me the two numbers that we have this one? How we are going to find two numbers whose sum is exactly this one and whose product is already 1? I think, can you find a number, this one? All right. Let's find how we are going to. Maybe I think we didn't make a mistake because certainly we have this one. Let's see if there is something wrong. Let's see again. X squared plus 2C, okay, 2C minus 4. And that is 4C minus 1. Then this is exactly B squared minus 4AC is greater than 0. B squared is this one. Let me check how this is done. 2C minus 4, 2C minus 4, 4C squared minus 8C. I think there is no, this is absolutely correct. Then here you can find what numbers that you're going to have. You know that this is already 4C squared minus 16C plus 16, that's negative 16 plus 4. This is going to be 4C squared minus 16C Let's you finish this part. Let's you finish how this is. I think it is very simple. You know how to do this problem. Do this problem. We'll come back to again. let's see the last question, how to do this formula. What is how to solve this equation? 6 root y plus 2 over radical of y minus 7, that is going to be 0. We'll come back again. How we are going to solve this one? This is a more complex quadratic equation. Is that? More complex quadratic equation. So how we are going to solve this formula? How we are going to solve this formula? You know, in order to solve this formula, you can multiply both sides by root y. So this is going to be 6 root y. Now that means you can multiply both sides by root y. So this is going to be 6y minus 2 minus 7 root y. That's going to be 0. Is that? I'm going to show you only the way how to do this formula. So look, 6y minus 2 minus 7 root y, that's going to be 0. So to do this formula, let's recall, let a is, that is now root y. So this implies that a square will be y. So and hence, now when you come back to this formula, 6 a square minus 2 minus 7a, that's gonna be 0. Rearranging this, 6a square minus 7a minus 2, which is going to be 0. Then you know that you can use how to find the product of this formula. Now you can use a quadratic formula, or you can use a factorization or a completing the square method. So let's use either of the methods. Now look this one. Let's just use b square minus 4ac. Sorry. Now let's just simply use this formula to solve this problem. a6, b is already negative 7, and c is that is negative 2. Then this is exactly now a is going to be minus b plus or minus square root of b square minus 4ac over 2a. This is exactly minus b mean 7 plus or minus square root of 49 minus 4 times a is already 6, c is already minus 2 over that is 12. So a will be what? A will be 7 plus or minus square root of 49 plus 24, 48 over 12. You know that this is 12 times this 48. That sign is plus. So this implies that a is going to be 7 plus or minus a square root of 97 over 12. So the negative sign will not be taken as a value. So from here you can say that a square y is equal to a square. So if a is already, now this implies that the value for y will be what? 7 plus or minus square root of 97 over 12 the whole square. What is that? This implies that y will be what? 7 plus square root of 97 the whole square, or what? Or y will be 7 minus square root of 97 over 12 the whole square. So the value for y will be either this one or that one. So this is the way how to find the value for these complex quadratic problem. So you know, generally in the case of this problem, we call this is a complex quadratic equation. So whenever you have already given such kind of problem, you have to use a substitution method in order to find such kind of problem. So this is all about our today's lesson. Maybe for the question that's before this one, let's try and finalize, and we're going to see together. If you have any more question about this one, you are welcome. If not, thank you for today. This is all about the revision of the first chapter. We're going to add another more questions based on another more question about the first lesson. for the coming my YouTube channel HMR 16. Just thank you for watching HMR 16. Thank you. Bye bye. See you again.